If you think about it, a network is really like a neighborhood. Suppose we have a street running through it called Oak Street, and it has 3 different houses. Each house has a unique address to distinguish it from the others on that same street. That way, postal workers know where they can deliver mail. For example, the address of this house is 732 Oak Street. Notice that this house's address has 2 different parts. First, there's the house number, and then there's the street name. Having a street name allows us to group all the house numbers into the Oak Street group. Just like a house in a neighborhood, networks also use a 2-part address to identify individual hosts on that network. For example, we might have a computer here on this network with the number 1 assigned to it. This is the host address. But the network it's connected to also has an ID or name, like Oak Street. In this case, it's 192.168.1. Just as a house in a neighborhood has a house number and a street name, a computer on a network has a host address and a network ID. If we combine the 2 together, we can uniquely identify that host on the network in the same way that a house number and a street name uniquely identifies a particular house in a neighborhood. Suppose there's a second street in this neighborhood called Elm Street, and it intersects with Oak Street and is connected to several other houses. Just as on Oak Street, each of these houses has its own number. You might notice here that this house on Elm Street has the exact same number as this house over here on Oak Street. Suppose you're a postal worker and you have an envelope addressed to house 732. Without a street address, you wouldn't know which of these houses should get that particular envelope. Should it be 732 Oak or 732 Elm? Because these houses each have a 2-part address, 732 Elm and 732 Oak, we can identify which house a particular piece of mail goes to. It works the same way on a computer network. We could have 2 computers on 2 different networks that have the same host number assigned to them. We could have a host on this network assigned the number 1 and a host on this network assigned the number 1 as well. But we can identify them uniquely from each other by looking at the network ID. The host on this side has a network ID of 192.168.1. The host on the other side has a network ID of 10.0.0. Notice in this diagram that these 2 networks are actually connected to each other, forming a larger network with all the other computers. This network could be connected to an even larger network. But if the only word we had to describe these connections were network, it would be difficult to know which network we're talking about. That's why we need to introduce some new terminology. Each of these separate networks represent a subnet. A subnet is a part of the network where all of the computers share the same network ID, in much the same manner that all of the houses on the same street share the same street address. Sometimes you'll hear a subnet ID referred to as a network address. They're the same thing. A best practice is to use the term subnet ID. These subnets are connected to each other by a device called a router. We can connect multiple networks together using multiple routers. If we zoom out, we see all of the different networks within a particular organization. When several networks within the same organization are connected together, they're collectively referred to as LAN, which stands for Local Area Network. There are many local area networks within the same city, and they're probably all interconnected together using some type of connectivity. In this situation, all of the networks within the same metropolitan area connected together constitute a metropolitan area network, sometimes called a MAN. If we zoom out even farther, we can see that there are many networks in many different cities, and they're all connected together. The connections between them are called Wide Area Network Links, or WAN links. The collection of connected networks is called a WAN. Another way that we use the term network is to describe the connected devices that are under the control of one particular organization. Let's pretend we have a sporting goods store here with its own local area network, and we also have a software company with its own network over here. In this case, we would use the term network to describe the boundary between these 2 individual organizations. We can still connect the 2, and when we do, we now have a WAN connection because there's a wide area link between the 2 organizations. When this happens, we don't refer to both networks together as a single network. Instead, we're going to use the term internetwork because we're taking 2 separate networks and we're connecting them together. Another term you need to be familiar with is the Internet. Of course, you've heard of the Internet. You probably used it today. But we're going to talk about the Internet in terms of networking. As its name implies, the Internet is an interconnection of networks. Remember, we talked about earlier that an internetwork is a connection between networks that aren't controlled by the same entity. That principle applies to the Internet. There are parts of the Internet that are managed by large corporations or even nonprofit groups. But in reality, the Internet is a collection of many different networks owned by many different entities that all share information and communicate together. The Internet connects devices all around the world. We might have a city here, and they all share a common way of connecting so that they can route signals between each other. At each spot, you have one or more ISPs, which are Internet service providers. ISPs don't manage the main part of the Internet network. Instead, they manage a particular access point. If you think of the Internet as a big freeway, the ISP would be the entity that manages the on-ramp. They're responsible for building the on-ramp and keeping it maintained and open, but they're not responsible for the whole Internet itself. The ISP is responsible for allowing both individual users as well as companies with large networks to connect to the Internet superstructure. For example, you contract with an ISP to connect your network to the Internet. In this scenario, there's typically a security boundary that separates your network from the public Internet network. You might have devices on your network that access network servers, such as web servers and email servers. They're connected to the Internet, but other computers can't come in and contact devices within your network. As you can see, this creates a division of sorts. Public networks share all devices and they're freely available. On the other hand, devices on a private network can access public network devices, but they themselves can only be accessed by other devices within the private network. There might be exceptions. For example, in this particular network, we might have a particular server that we want to make available to the public, such as a server that hosts a website for our organization. In order to do this, I would actually need to place my web server outside of this security boundary so that devices in other locations can reach this website through the Internet. In essence, I've made part of my network public and created a small public network, if you will. A related term you might hear from time to time is intranet. An intranet is really kind of like a miniature internet. An intranet is a private network, but it uses many of the same technologies that are used on the Internet. This intranet might or might not be connected to the public Internet. For example, we could have an email server within our private network so that only people within my private network can access it, even though my network is actually connected to the Internet. This way, I'm using Internet technology on my local private network. Again, this security boundary here would prevent devices on the Internet from accessing the devices within my intranet. Another term you might hear is that of extranet. An extranet is essentially an intranet that's made partially available to entities outside of your organization. For example, let's say we have a company here, and it's connected to the Internet. This company has a partner company in another location, and we may need to take some of the information within our intranet and make it available through the Internet to that partner organization. To do this, we could establish an extranet that's connected to the Internet. We implement controls on the extranet to make sure that its partner organization over here can only access the information we want it to. Any other devices that aren't part of the extranet don't belong to the authorized partner corporation. They wouldn't be allowed to access the resources within my extranet. That's it for this lesson. In this video, we talked about addressing LANs, MANs, and WANs. We also talked about the Intranet, Intranets, and lastly, extranets. Now that we've introduced you to many different networking terms, you're ready to dive deeper into the networking world.